From North Australian Heavy Mechanical. Today I'm going to run through one of the reels that I did and give you a bit of information on closed loop hydraulic circuits. And my experience is Liebherrs and ONKs, they're very much the same system, they just like to name things a little bit different. So to start off with, I'm going to give you a bit of an explanation on how the pumps work. They are a piston pump, they work slightly different to the standard conventional piston pump. So on a piston pump, in my head, this is how it works and how I like to explain it. Standard piston pump, you have your swash plate and your pistons, and when you stroke it, you go like this. The inlet port, the area in the piston becomes greater, so it sucks more oil in and pushes more oil out. So these are the same, right? So your pump, when it swashes one way to slew one way, it goes like this, creating more oil in here and more oil out there. Then it just switches. So when you slew the other way, this port then becomes the inlet and this one becomes the outlet. So it sucks oil in through this port and then out that port. So with these pumps, keep in mind they have a charge pump because they don't have a conventional suction, and that charge pump charges it with oil and or replenishes it depending with fresh oil from the hydraulic tank to cool and lubricate this system. So it's lost through your cases, and that's how they cool and lubricate it. So these pumps also have secondaries. So pretty much the same as the same setup, they're just there to protect the system from spikes. So a little bit more info on the TCVs. They have their max pressure in there on the Liebherrs, which is like a little valve there. They have their proportionals Y151 and 155, that's for left and right slew, and then they have a counterbalance valve. So the counterbalance valve is what keeps it in the neutral position and then helps you slew right and left. That proportionals act on the counterbalance valve, and that's how you get your left and right slew. So the same said for the ONKs, they just call them a little bit different. They have the counterbalance valve, they have their proportional valves, and then they have the pressure limit, it's called a pressure limiting valve, which is pretty much the same thing. Yeah, so these also run, so for a twin engine excavator, they run what's called blocking valves on the ONKs. So blocking valves, what they do is when you're running one engine, that pump that's on the engine that's not running, if the flow is not shut off to that pump, it will turn into a motor and turn the engine over. So that's what the blocking valves do. When both engines are running, both blocking valves are open because they do it via pilot pressure from that engine. But then when you're running single engine operation, one set of the blocking valve shut off. So that stops the other engine turning into a motor and turning that engine over. On the Liebherrs, they just have little check valves in the pump, and that does exactly the same thing. So if you are getting one engine that's turning over, especially after a shutdown, I've had this, you go and check out your blocking valves, make sure your lines are correct, and then on the Liebherrs, go and check those. They actually give you a little replacement kit. Go and check those up in the pump there. So moving forward, we then move on to our motors side of things. I'll give you a few pointers with the motors, right? The motors have crossover hoses, and the reason being is no two pump or motor is made the same, right? So for example, one pump might be set at 100 litres a minute, and then the other pump might be at 102 litres a minute. So if those two slew boxes are working together, they'll be fighting against each other. One will be working harder than the other. So this leads to premature failure. So what you do by linking these two up is equalise the flow going to these two. So they've both got the equal amount of flow going to them, so they work together much better. So I'll go over some faults and give you a bit of an idea of what to do, how to approach an excavator when you do get a complaint. So for starters, a lot of complaints are hydraulic overheating of the slew circuit. So because this system is sensitive, it requires replenishing oil to replace the oil that's in it through the cases. It's very sensitive. So for example, your hydraulic mightn't be overheating, but the hydraulic cooler might be blocked. So bringing that hydraulic temperature up just a bit will dramatically affect your slew circuit. So for starters, always go and check your coolers when you're dealing with an overheat on these. And then moving forward, we go and check our charge and replenishing pressures and our max pressures. So another one that I've had with these is erratic slew and some weird behaviours. They are difficult to chase, but this is why I like to use analog gauges. So digital gauges are brilliant. Don't get me wrong, there's times where I use digital gauges because they're just so much easier. But when it comes to a slew circuit, analog gauges all the way. So for example, one was slewing erratically and would randomly slew one way, and boys spent some time on it. I did too, and was using digital gauges. So I switched over to analog gauges, and when you run one engine, slew left, you could see a spike, and it was not noticeable with the digital gauges. It looked fine, but when you went to the analog gauges, you could see that spike and fluctuation. So I find analog gauges are brilliant for slew circuits. So some other complaints that you'll get with these systems is noisy slew. Now, to start off with, it's just visual checks. So go and check your oil reservoirs and look for burnt oil. I think, from my experience over the years, oil sampling is a complete rort, and it's never identified a failure before it's happened. It just depends whether, you know, where the person's taken it from. They might have taken it from the service hatch or anything like that, and they'll just often tell you, "I'll sample and resample and change the oil." So that's why I always refer back to the oil reservoir. Never worry about the oil samples. Go and check your oil reservoirs and take your thermal or your temp gun with you. Go and temp shoot your boxes. So anything sort of 5+ degrees hotter between slew boxes. So you got one that's 65 and the other one that's 75. Straight up, that box has got a drama. Go and drop the oil in it and look for metal. So again, with the bearings, another good point. I've not had too many of these fail over the years, but I have. They sort of sit a little bit hotter than ambient temperature, like any pin or bush does. You know, they sit just that little bit hotter than ambient temperature. If it's like 15, 20 degrees above ambient temperature, you got to do some more investigation. Go and pull your grease covers and go and check the condition of the grease and get a magnet and see if you got metal in there. So yeah, it's super essential when it comes to noisy slew. Make sure you get in there and temp shoot things and pick it up before it becomes a problem, because when these slew boxes lock up, they will destroy a bearing, and it becomes like massive downtime and really in-depth work. Then, you know, line boring bores that have those massive bores is extremely difficult, and changing bearings out is really expensive work. So yeah, I'll just go back over a few things. So they require these pumps. They swash both ways, inlet and outlet switches. That's how you get your left and right slew. They require replenishing oil to charge and to lubricate and cool the system. They have secondaries the same as the attachment. They just protect from spikes. The TCVs on the Lee bears, they basically your logic block, pretty much the same setup on your O&Ks. They have the proportionals, the counterbalance valve, they have a pressure limiting valve. Then blocking valves, they stop when you're blocking valves, or check valves, they stop when you're stop the other engine from turning into a motor and turning it over when you're running single engine operation. Motors have crossovers. This equalises the flow because no two pumps is made the same. Hydraulic heat, always start out with checking your coolers, charge oils. When approaching noisy slew, make sure you go and visually inspect your reservoirs and then temp shoot your boxes and bearings. Make sure the boxes are not too much, 5 degrees more than the other boxes. Yeah, you've got a drama. And then bearings, always, if it's dramatically above your ambient air temperature, and that applies to all pins and bushes really. If you have one that is like 5+ degrees hotter than the rest, you know that there is a drama going on with that bearing. So hopefully you've enjoyed this video and got something out of it. If you did, like, share, comment, and subscribe. So thanks very much. I'll see you again soon. Cheers.